Okay, we're doing a quick video now on how to do a simple if statement. Let's begin by looking at what an if statement looks like in C++. The simplest if, the one-sided if, says if a condition is true, uh, do some consequence. In this case, we call it a block. Otherwise, do nothing. Otherwise, really just skip past this statement. So the assembly language code pattern has to be evaluate the condition, which will result in a true or false value being placed where? In the accumulator. Then we branch on false around the block. That is, we do nothing if the condition is false. Otherwise, we let the code flow into the block. And because this is one-sided, after we execute the block, we are at the statement labeled done. Statement labels end in a colon. They really ought to be uppercase just to make sure they should be uppercase, but they cannot be the name of an instruction. Be careful about that. So let's pull up some code template and see what this looks like. So here's the code. I want to read this. Now let's do this together. I have how many variables? 1. So I must have a data section. In it I will say allocate so much space for data. In this case we could say 1 and be fine. Now we must create the variables and name them. So we're going to say X is a data value. We don't need to initialize it. So that's all we've done with the data. Now in the let's see what we got here. Move this over here. Over a little bit. Off the screen. Okay. Real estate management is pretty bad right now. Let's move this over. So what are we going to do here? We're going to have a label called done. We have the label here. And we're going to follow the pattern. Evaluate the, I'm sorry, I'm kind of crossed up here. Evaluate the condition. So how do we evaluate the condition? Well, first of all, the condition is what? I want to compare X to 0. Now, there's two ways of doing it, and let's just show you something different than what I told you in class, because this may just make life easier. It's probably better to say I want a variable called 0, and I'm going to initialize it to what? 0. All right? So some of the constants you're using in your program, you can just store those as predefined variables. And now, how do I evaluate this? I need to compare to see if X is greater than 0. Do we have an instruction for that? Of course we do. So first of all, we got to say load X, put it in the accumulator. Then we compare what's in the accumulator for greater than. Make sure X is greater than what? 0. The result of that will be that the accumulator will be true or false. So what's our pattern? Jump around the consequence. Jump around this if the condition is false. So what's the instruction? Branch on false. Branch on false to done. Go down here and fix this. And now where's the consequence? Consequence is what? I'm going to skip a line just to let you know there's breathing room. What are we going to do? We're going to say print the value of X. So we're going to say write X. That's all we're going to do. All right? Now, let's not do it that way. I'm going to do it this way. May not make a difference. So what have we here? The thing we have now is the code that should read a value for X. I didn't read, did I? I might want to pay attention to what I'm doing. Read X and go from there. Now let's go ahead and try to compile this, to assemble this. Okay, it looks like it assembled, so let's try to run it. I'm going to enter number 14. If 14 is greater than 0, we will display it. Satisfied? Let's try it again. I'm going to enter 0. What's the output? I read a 0, but I do not display anything. So it looks like this if statement is working. Are you convinced? Now let's bump it up a little bit. Let's bump it up. Bump it up. Let's do an if else. Okay? Because if you're going to do an if else, I suggest that you just worry about doing the if first. Do the first part first. Okay? Do we have the first part done? Yes, we have it done. So let's go back to the code. And we have that done. So we basically are going to add this. We're going to say else print 2 times x. Okay? That's what I want to print. So notice that what we have here listed as done is really where I want to jump. Do I want to jump to the end of the program, or do I want to jump to where the else is? We really want to jump to the else. I'm going to call this else. So here is the else. Else is going to say what? I do what for else I'm going to do the print 2 times x. Okay? So how do we do that? How many of y'all remember there's a special instruction called double? Where is it? Double. This instruction takes what's in memory and doubles it. So why don't we use it? So if the condition is false, the else says double it. So we're going to say double x, and then we're going to write x. Okay? And then we're done. Now, what about this? This is the consequence here, though, isn't it? This is what we do when it's true. If we aren't careful, we will flow into the else. So we'll do the if part and the else part. So what must we do? We got to jump around the else part. We're going to jump where? To done. The instruction for jumping is called branch. We can branch to done. All right? Be careful about something. The labels, the colon appears only in this column. When you reference the label, you do not put the colon. The colon establishes the label. It defines the label. All right? So let's take a review. If I have an if else, I need how many branches? I need a branch on false to go to the else part. That's one branch. I need an unconditional branch to jump around the else part if it exists. Okay? So an if else has 2 branches, one conditional, one unconditional. Let's get out here. Let's write this as if else. How? I'm going to assemble this. And we're going to try to run it and see what happens. Apologies for the speed. Now we're going to run it. And I'm going to enter number 14, and I see 14 coming out because it's greater than 0. We're going to run it again. I'm going to enter the minus 17. What comes out? Double minus 17, which is a minus 34. So this code has done the trick for us. All right, with this, we're going to quit. Right? Now, but let's go ahead and look at the pattern again. If the condition is false, you always jump around the consequence. Sometimes jumping around it will take you to the end of the entire if construct. Otherwise, it will take you to where the alternative is. It kind of makes sense to label the parts of your code to reflect what the C++ look like so you can see the correspondence. It's okay to use the word else. Make sure it's uppercase. If I have several conditions or several loops, it's okay to put a 1, 2, 3 on things. Clear? All right, with that, we're going to stop this train.